Hi everyone, my name is Santosh Kuppens and I'm a geophysicist working with QI based in Copenhagen, Denmark. I'm going to spend the next 3 to 4 minutes discussing the key benefits of the QI inversion engine, and afterwards our team will be on hand to address any questions you may have in the chat window. The variation of seismic amplitude with incidence angle, called AVO, at a geological interface contains the information on the rock and fluid properties in the layers. Seismic inversion uses this AVO information to convert the seismic data from amplitudes at an interface to properties in the layer. The process is controlled and calibrated by well-logged data. The output of a seismic inversion is an estimate on the elastic and petrophysical properties in the subsurface, but away from the wellbore. The QI inversion engine is a globally optimized full bandwidth algorithm. It inverts all input seismic stacks simultaneously for the best fitting Earth model. It uses the simulated annealing algorithm, which belongs to the class of global optimization schemes capable of locating a global minimum in an object function. This is a powerful way of addressing the non-uniqueness inherent in the inversion problem. The inversion engine can simultaneously invert an arbitrary number of angle and azimuth stacks and an arbitrary number of data vintages if you are performing a 4D inversion. And it can simultaneously invert both PP and PS datasets if they are available. Each individual stack has its own wavelet, and each wavelet may vary in time or space. This high degree of flexibility allows you to optimally angle stack your data to find the best trade-off between AVO domain sampling and noise suppression. The QI algorithm does not linearize the inversion, nor does it make any prior assumptions of the relationship between the terms. Either of those two simplifications would compromise the inversion result. Finally, the user is able to independently weight each penalty term of the object function with sample-by-sample coefficients based on data attributes such as fold, signal-to-noise ratio, bandwidth, fault proximity, etc. This level of customization recognizes the spatial and temporal variability in data quality and adjusts the inversion accordingly. The inversion can be performed using one of a number of AVO models to enable an optimal choice for a given data. The engine efficiently handles the largest datasets without segmentation of input data. And finally, the inversion is fully symmetric with no concept of a reference stack or baseline vintage in the 4D case. This improves the behavior of the inversion in the presence of noise. Download our flyer and please do follow us on LinkedIn. Please leave your name and contact details in the chat box so we know that you passed by. Join us in the chat room at any time this week to follow up or reach out to us using the methods shown on the screen, and we'll gladly take the time for a more detailed discussion and show a case study.